A piece of metal is heated and then allowed to cool. 1 minute after being removed from the heat, the temperature is modelled by the equation T equals A times 0.8 to the power of T minus 1, where capital T is the temperature in degrees Celsius and little t is the time in minutes. Okay, now the initial temperature, that means the time when T equals 0, that's what it always means, of the metal is 160 degrees Celsius. And we need to find the value of A. So this is an exponential equation. That's the type of question this is. So exponential because notice the exponent has a letter in it. In fact, it's a variable. The variable of time is in the exponent. That's how you can tell when something is exponential. It has a variable in the exponent. Okay, so that's worth knowing. It's knowing what sort of question you're dealing with. Okay, let's start by writing out what we know. So we know A times 0.8 to the power of T minus 1. We know that gives us our temperature, right? And we know that the temperature at the start, when T equals 0, is what? We know it is 160 degrees. So I'm going to substitute that in. So 0 minus 1, because the initial temperature is at T equals 0, and that equals 160. Now I've got to solve to find what A is. How am I going to do that? Well, pause the video and have a go. Go on. Okay, so next step would be to simplify that. So A times 0.8 to the power of negative 1 equals 160. And I don't need to actually evaluate what that to the power of negative 1 bit is. All I need to do, I've got A times something equals something. How do I solve for A? What's the opposite to times? It's divide, isn't it? So I need to divide both sides by 0.8 to the power of negative 1. So I'll write that down. So A equals 160 divided by 0.8 to the power of negative 1. Grab out the calculator and whack it in. So 160 divided by, oh there we go, 0.8 to the negative 1, and I get 128. So that, there it is. So 128. So that's the value of A. Okay. So that means then the full equation, which is what we're going to deal with in the next question, is just going to be T equals 128 times 0.8 to the power of T minus 1. And the next question, usually the second part will be to solve that. So how long will it take for the metal to reach a temperature of 100 degrees Celsius? So let's substitute in T equals 100. So 128 times 0.8 to the power of T minus 1 equals 100. And what I want you to do now is pause the video and have a go at solving this. So this is your classic exponential equation question, which you usually get a couple of in every algebra exam. So they're worth practicing well because they're a guaranteed E7. Okay, so hopefully you've had a go at it now and you're just checking to see whether your working's right, or either that or you've got stuck. So the first thing we have to do always with an exponential equation is we have to isolate the powered term. So the powered term means the one that has the exponent attached to it. So that's the first step. Okay, I'll try to pause it so I could type that, but it's not going to let me pause it. So you are going to have to just fast forward this bit. I'm just going to draw that in because I think that's good notes to have. So always start by isolating the powered term in an exponential equation. Get it on its own. term with the exponent. So how am I going to do that? Well, I've got to divide both sides by 128, right? So it's going to say 0.8 to the power of t minus 1 equals 100 divided by 128. Okay, and now I've isolated the powered term. Now I take the logs of both sides, which just means, so log of this side equals log of that side. I'm doing the same thing to both sides, which is fine. I can do what I want to an equation as long as I treat both sides the same. Now I'm gonna rather than evaluating 100 divided by 128, it's going to be a messy decimal. I'm just going to leave it as log of 100 over 128 in brackets. Okay, what can I do now? Well, I know that this can be rewritten as t minus 1 times log of 0.8, can't it? And that's the step you always have to do. It's a step you have to memorize. That property of logs. Okay, now what? We're nearly there. So we've got t minus 1 is what we're trying to work out. That times something equals something else. How do we undo times? Divide. So t minus 1 must equal log of 100 over 128 divided by log of 0.8. And so we whack that into a calculator, and it doesn't matter which log button you use as long as you're consistent. So you could use the LN button if you wanted to as well, but as long as you use you're consistent with that within the same question. And so I get this answer here, 1.106. Now that's going to be t minus 1, isn't it? So I want to get t, because little t is my time, and the question said how long will it take. So I need to go what? I need to go plus 1. And so that's my answer. So t equals, it won't let me pause it again, sorry guys, so I'm gonna have to watch while I type it out. So 2.106, 106, and then I better read the question to see what the units are. The units are time in minutes, so minutes. And then always look and see if your answer is sensible, because if you've made a silly mistake, it won't be sensible. And one way of testing that is to actually sub 2.106 into the equation and see if it gives us the answer of 100 degrees Celsius. So I'm going to do that. So I'm going to take the original equation, which was 128 times 0.8 times 0.8 to the power of t minus 1. So 2.106 minus 1, brackets, and see if that gives me, and it does, it gives me 100, and the difference will just be rounding. So that means I know I'm correct. So you can always check an exponential equation question like that, and that's great because that knows that means it's a guaranteed E7. That's always excellence. Okay, as long as I've shown my working, I've at least one line showing I've used logs, I've got my answer in context, and I've set up my original equation, then I'll have that T. Nice. Practice heaps of these questions because they're just really good ones, because if you know what you're doing with them, then you're gonna, that's, like I say, that's probably a guaranteed 14 points in the exam. Okay, see ya.